Okay, so tonight we're just going to finish up with Module 1, which is the first chapter, I guess, chapter 8 in the book that we got started on. Got into some interesting topics last time, and then we're going to finish that tonight. Before I go into that, let me just review what the list of topics is. So last time we went over a bunch of different ways that you can pass data to methods, by reference, by value, why you might want to do it, how, what the different outcomes are. That was fun. And then both directions, right? So there's implications when you're implementing the method that receives stuff as out parameters or by ref parameters. And then there's, when you're the calling function, there's things that you have to know, whether your variable needs to be initialized or not, or whether it's going to possibly change on you. And one of the key things to take away from that is that C# requires you, both the caller and the callee, to confirm that they realize that it's an out param or a ref param by using the out or ref keyword. That way there's no hanky-panky going on where you go in there and secretly change the function to take it by reference. That way you can modify the results before you send it back and create a gotcha situation for the caller, right? No, we don't do that. If you add the ref to the function, you have to add the ref to where it's called to make sure that both parties know that what's going on. Yeah, and then the optional parameters where you can specify default values for certain parameters, and that way if it's not passed in, then it'll assign it to what the default value is that you give it. That was fun. I think we also talked a little bit about parameter lists. I know I at least mentioned them, but in case I didn't do that last time, I'll be happy to go over that again. So this time the list of things I wanted to go over was returning a reference from a method as the return value. Some interesting stuff to look at there, some interesting permutations. Overloading methods, and when you're overloading methods, you can create situations of ambiguity where the compiler, you're using the same function name, which one is the compiler supposed to use? And there's a process for determining what the appropriate one is. And the compiler is usually pretty good. It'll warn you if there's a ambiguity that it can't resolve based on how you're calling it. So we'll get into that also. And I think along the way I'm going to throw in a couple of other interesting techniques. I don't know that the book mentions these things, but it's interesting stuff to know if you're a C# developer. And I would put them in the category of, we have the discussion assignment about exploring, new updates in C# to the language and features in the Visual Studio editors and things like that. These aren't necessarily new features. They've been around for a while, but they were new at some point in my career, and I thought, man, this is the greatest thing since sliced bread. These people are geniuses. So it happens. Okay, I'll leave that there for a moment. Just coming in here and looking in Canvas really quick, going to modules. There's the, at the beginning of the first module, the first week check-in, the other stuff here. There's a bunch of, I know it's kind of tedious your first week in the semester and you are told to go read a whole bunch of stuff. It's a little dry and watching these videos and things. You never know when you're going to pick up something that it's like, why isn't this working? Oh, they said it in the video, how to get around that. So just make sure, you can bump up your playback speed too to suit your level of boredom and ability to absorb the information. But then here in Module 1, you've got the link to the chapter in the book. It's Unit 8, but it's Chapter 8, whatever. I get confused between chapter and unit and module and all these different classes because, I teach several classes and the terminology is not always the same. So apologies in advance if I'm saying Module 8 and I mean Chapter 8 and it says Unit 8 in here. If it's confusing to me, realize it's confusing to me too. Yeah, the link to the lecture. Somebody asked last time where these lecture links show up in here. So, under the to watch and read, if I record something during the lecture portion and I upload it, then I just throw the link in here in that module. So after tonight, if this recording comes out okay, then I'll put it underneath this one. So we'll have two for Unit 1. Then, as you probably have seen, hopefully you've started looking through these and working them, but it's up to you just to start munching through these and completing them as best you can. Don't get caught by the gotcha of spending all of your available time working on all these exercises and not noticing that there's the quiz and the discussion assignment out there. I would read the chapter before you do the quiz, but as soon as you've read it, you can jump down here and take the quiz. There's probably some value to doing the exercises and applying the knowledge before you take the quiz, but I'm just saying, if you're budgeting your time, make sure that you leave enough to spend 15, 20 minutes taking the quiz at the end and then completing the discussion, because those are separate grades. If you're looking at the points, it's a little weird to me too that these programming exercises and things are 100 points each, and then you come down, the quiz is only 20. Just realize that it's relative. So the quizzes are one part of your grade, so it doesn't matter if all the quizzes are 20 points. It's 20 points relative to the other quizzes. The discussions are under your participation grade. If they're all 20 points, it's 20 points relative to the other discussion assignments. And these programming little tasks, if they're 100 points, fine. It's 100 points relative to the other tasks in the list. So when you're looking under grades, it's a lot more clear to see. I won't open that because it'll show everybody's grades, but it'll show each section of grades and what you've currently got in each one of them relative to their weight, and all that's defined in the syllabus too. But okay, so again, we'll finish up on Module 1 tonight, and hopefully this will be fun. Okay, different method variations. So I've got a Visual Studio project that I created to try to help with some of this. Let me see if I can make it bigger. So this is nothing too terribly advanced. It's just simply a main function. I create a couple of floats, 17 and 3. I divide 17 by 3 and get another float, and then I print, the output. But I wanted to use this as a starting point to start. Okay, let me show you different variations of how to create different methods. The first one is we don't care about the result. And remember last time I said there are many different ways different flavors of functions that we can create, but I'd group them into 3 kinds. There's methods that don't return anything at all. They do a task, they perform an operation, they log some data, whatever, but they don't return anything. You don't care what the result was. That's one kind. Another kind is it returns a single value that you want back from the function. And we can define our functions as returning simple data types to accomplish that, no big deal. And then the calling function would assign what comes back to a variable typically, or use it in an expression and go on with its life. And then the third kind is when I have multiple pieces of data to return. And that's where it gets interesting, and there's many, many ways, at least a half a dozen different ways, and you might be able to come up with some other variations if you thought about it, for returning multiple pieces of data. And I think a lot of these have been developed over the years in competition with or watching what has gone on with other languages and trying to provide the same power to C# as these other languages have. But we'll get into that as we go through. So the first one is I'm just going to call try dividing right? So I call it, what's it got a problem with? Oh, yeah, I noticed that earlier too. These have to be static. Okay, so I just call it. And maybe that's what I wanted. Maybe all I wanted to see is, hey, can I divide these two numbers without throwing an exception, without something being wrong with the operation? And, fire and forget, it does it, great, it worked, wonderful. That's all I needed to know. I can divide these two numbers. Okay, so that's one way to do it. I'll have to fix each one of these. The next one is, I would call this one the pretty standard return one value. Come up here, and instead of this value, let me move this up. Instead of this expression, let me just say divide. So I pass it two parameters, and I get back one parameter, one value. That's all I needed to know. Pretty vanilla. For your first attempt to implement an algorithm for class, you might pick a pretty straightforward one. But then you get to thinking about it. It's like, if this guy passes 0, what's going to happen? Well, this is going to throw an exception, right? Has anybody worked in a language where it won't even let you do this because it realizes, hey, you're passing 0 here, a literal numeric value, and I'm going to look ahead at what the code's going to do, and you're going to use that as the denominator in a division operation. So I'm going to throw a compiler warning to say, you might want to look at your logic. You've created a possible problem here. Anybody worked in a language or seen something that warns you like that? Let me see if C# is that smart. Nope, it didn't catch it. There are some languages that do catch that. I don't remember if C++ is one of those or what, but yeah, if I call this right now, it's going to crash. It's going to throw a division by 0 exception, and the program will exit. So I don't want to allow that to happen. So maybe that's not the safest way to implement this. But I do still need the result, right? Okay, so I could, okay, well, this is just another variation. Let me do that one. So hold the powder there, and let's look at this variation just so I can stay in order. So instead of doing it that way where I pass the two parameters and I get back the result, let's do the by ref one. And here I'm just going to pass by reference the result. Now the difference here is I have to declare the variable first myself. So that's kind of a pain. And then I have to pass my value, divide by ref. Okay? Great. And just another way of doing the same thing, but I have the same problem. All right, so let's fix that. So I'm going to divide by ref safe. I have to put the static on. Yeah. Divide by ref safe. And this one now checks. It says the result that I want back is, well, if denominator is 0, then return 0, else return the actual value. So now this one won't throw an exception, but it's going to return 0 if I pass 0 as the denominator, which is not really the right answer, is it? 8 divided by 0 is not 0. It's, you did something wrong. It's a wrong expression. There is no answer. I mean, I guess infinity is the answer. But that's how we would call it. That's how we would fix this issue. Does everybody remember this operator? the question mark colon operator. This is nothing different than saying if denominator equals 0, result equals 0f, or I guess you would say return 0f, else return numerator over denominator. Those are the exact same thing. It's saying result equals, pause, evaluate this expression. If that expression, and it has to be a Boolean or something you can interpret as a Boolean. If that expression evaluates to be true, then what I want to assign to result is this value, else this value. And the cool thing is this is short-circuiting. So if this is, it definitely evaluates this expression. If it's true, it never performs this calculation. Which, I mean, if you're thinking, well, yeah, because it's the equivalent of this, that makes sense. If you go down this code path, you're going to execute this line of code. You're never going to execute that line of code. But, it's still good to observe that, it short circuits. It just evaluate everything on that line. It does it in order. So, when you're a teacher and screen real estate is a premium, that's a lot better. But I understand, taking the little aside and explaining what the heck that line of code means is probably warranted. Very common, most programmers are going to do it this way if they can. So just keep that in mind. You can have any true-false expression here, and then this one or this one, or this one else this one is what it's going to evaluate. Okay, any questions about that? Okay. So yeah, that fixes our problem. Now we have a by ref version of the method that won't throw an exception if you pass 0. However, it's still got the problem of returning the wrong answer. So now how would I know whether, it's ambiguous, right? If I pass in 17 and 0, I get a value of 0 back and it's the wrong answer. But if I pass a value of 0 and 12, I get 0 back and it is the correct answer. So I don't know whether it returned 0 because it couldn't evaluate it, or it returned 0 because I can rely on that being the correct answer. So I fixed something, but I've kind of left a little bit of ambiguity there. It's still buggy. It's still not great. So the next one, safe and robust. And this is where we jump over into the category of functions that return multiple values. Okay? Because I want to return the value if I can, and then I also want to return something that indicates whether 0 means error or whether 0 means 0. Right? So I'm going to return two pieces of information. So my function is going to pass a by ref result value, and it's also going to return a bool. And I got to add the static. Okay, so now I can say something like if let's say if if that, then I write the answer, else something like that. Excellent. And that's how I illustrate returning two values, the result and a bool that says whether that's okay or not. So this one's much better. And it's doing the similar thing. It's just saying, hey, calculate the answer like I did in the previous one, but also return true if that's equal to 0, false if it's not. So actually, I guess this is wrong. This is backwards. Maybe I want to return not. What is it? Yeah, because I want to return true if the value is okay to use. So if this returns true, I can rely on the result. If it returns false, something bad happened. Everybody with me? Did I do that right? Or did I have it right to start with and broke it? I'm going to say that that's correct. All right, so now another thing I wanted to show you, which I think is pretty cool. Let's call that one good. Is this little variation here. So it's a little different. Let me go up and change my call. Edit, advanced, comment selection. Everybody know you can do that in the editor? You can just select a bunch of lines and comment them out. It's kind of handy. Divide anonymous. Okay, but it returns something. It says that it returns an object. And this syntax, now have you guys already covered that in the first class? Or is this new? In C#, this is what we call an anonymous type. Anytime you see the new and a curly brace, we're basically going to create a new class on the fly. Well, classes have methods and properties, and we have to give them names and stuff like that. So we had to change the syntax inside here too to say, I'm going to create something as a property of this object called error code, and I'm going to assign what value I want this instance of it to have. Then I'm going to assign something or create a property called result, and I'm going to assign the value I want this instance of it to have too. So a lot going on in one statement, essentially. It causes the compiler to go off behind the scenes and create a class with no name. I mean, it's got an internal like hex value for the name, and automatically creates a couple of setters and getter properties for these two values that I gave it. And I can keep adding more. I can add as many as I want to. I can nest additional anonymous types inside there. You know, it's very powerful. This has been out for quite a while and is very cool. But you can see how this really makes your code compact. If I had to go off and create a class called result of division and add the getters and setters and all that, I'd have to create a new source file and 20 lines of code plus documentation, you know, to implement a class in order to return that object from this method. I didn't have to do any of that. So when this came out, this was like, wow, that's awesome. I'm going to use that. So how to receive that back? Well, a hint is the keyword object here as to what it returns. So if I come back up here, I can say object result equals divide anonymous, and let's steal our little print statement here. I guess I can steal this whole thing. And again, I can select all these commented out lines and go edit, advanced, uncomment selection. But now how do I interrogate the result? How about dot? Dot error code? And result dot value. Oh, I called it result. So that would be the naive guess as to how to do this, but it doesn't seem to like it. So thoughts on what the problem is here, where the disconnect is happening? I mean, let's talk about why that should have worked and why it didn't work. Because we know that we're creating an anonymous type and we're returning that instance of that new type object back. We didn't get an error on that part. The compiler likes that. The compiler just doesn't like when we tried to use and reference the getter and setter inside that anonymous type. Yeah, so it's a limitation, but we told it that this is an object. Like if I said, how about if I said var result? Okay, it still doesn't like it, but now I'm not calling it an object. I'm just saying, hey, you figure out what it is. Okay. What if I say var result equals new Okay, that worked. I've created another anonymous type, the same as this one down here. It's got an arrow code that's set to a Boolean and a result that's set to a float, either this or this. Okay. And it says, yeah, okay, I got you. I can buy that. If I hold my mouse over result, it tells me, oh, I can tell you what type that is. It's a object with no name with an error code and a result. So the IntelliSense is smart enough to figure out what that is from the anonymous type stuff. But now we get an error on this because it's expecting an object. So it's like I have to cast this. What if I try just casting it as one of those? No? Any ideas? We're going to have to go to the master of all knowledge. C#, assign to, or how about return anonymous type from method. A new keyword. So I don't want to really go into recommending you use dynamic yet, because it'll work here possibly, but it's used for something else like COM objects. But this is the part here that I think we want. There's this cast. Or we can use reflection, but I don't want to do that either. Let's try this. Okay, so they're going to use generics to do this. So they're creating a function. So they're going to call a function that's going to do the work for us. Oops, just trying to make this a little bit more readable. But now it says that doesn't exist. Okay, well, yeah, that's because they created this thing. Am I missing a reference here? Oh. Yeah. So now it works. So they use some generics magic to say, take this thing that returns an object and cast it to this thing that's of an anonymous type. But generics allows you to refer to the type generically and do the operation on whatever type that happens to be. So it's using a little bit of substitution magic to get us around the problem of, wait, I've got an object and I need to consider it as this weird, anonymous, unnamed type. So that's the magic glue that gets us past that problem. Now, result.errorcode resolves, the compiler knows how to find that, and result.result resolves. It knows how to do that. So how many people did I lose? This is a lot of new stuff. I don't blame you for thinking, wow, that's wild. But see how powerful it is and the kind of stuff that you can do with it? Yeah.
What is the cast mostly used for?
Well, I could have called it yellow.
Oh.
Whatever. I came up with that name. Well, they did, and I
Okay.
plagiarized it. But that's just the name of this method of this thing that I defined. So it says, return this object as if it's this type, and I'm going to tell you what type to consider it generically. You know, this is exactly the same thing I was trying to do, where I just put, I'll bet there's a way I can still do it all in one line without this thing. You know, I was just trying to put it in parentheses, but I think if I do that and say dot type of or something and say, yeah, this expression, give me its type, then I probably could have put that in parentheses, and then I'm just doing a simple cast operation. I'm saying, hey, this object, consider it as this. Or let's go back to the example where I create an actual class. I create a new source file in my project of type division result, and I add those two properties to it. Well, now I can just take the object and cast it as a division result, and it would all just work fine. The only reason I have to kind of do this little jumping through hoops is because I'm doing it with anonymous types. It doesn't have a name, so I need to refer to the type abstractly. So on one hand, it's like, whew. On the other hand, it's like, wow, that's really cool. That somebody sitting in a cubicle at Microsoft thought, what if we did this? What would we have to do to make that work? And they imagined all this stuff, and then they built the compiler to be able to do it. To me, it's just amazing. It's just genius. If you ever have a chance in your computer science degree to take a compiler construction class, it's really interesting. You learn about parsing stuff that you consider a source code and then trying to treat it symbolically and then perform the operations that it tells you it wanted to do. And it's very interesting, and the patterns that they've created for allowing you to write a compiler in order to do that, it's like, wow, that's actually simpler than I thought it was going to be. And I could do that. I could create my own language and, build the compiler for it. But then once you get a glimpse of doing that, you realize the people that are creating a compiler to do this kind of stuff, man, those are some smart cookies. Okay, I think I have flogged that example to death. And any other questions about this? I'm also taking the shortcut of actually running the code. That's just a detail. I just assume that it works, so. Okay, let's do this next one. Okay, so one of the problems with that is the weak typing, right? It's weakly typed. I get this thing back. I could have called any function. Let me go back to cast. I don't want to leave that because it's performing the casting operation for us. The type casting, right there is where it's doing it. Yeah, but it's all weakly typed, and we had to go through quite a bit of hoops to make it understand what type we were returning. If I called some other function that also returned an object here, it would have tried to do the same operation, but would have failed, and I got a compiler error saying, wait, that object that you're returning, at runtime, I can't perform those operations, and so, sorry, no, it's going to throw exceptions. So maybe there's a better way to do that with a strongly typed solution. And yes, there is. So here's another way of doing the same thing. I don't need all of this stuff. Get rid of all this. Okay, tuple, and I'm going to return a bool and a float. What is the syntax to get the dot item one? Okay, fine. It's not very interesting, but oh, I have to make it static. There we go. So this is actually a pretty good way to do this. There's this tuple class, and Java does this quite a bit. Other languages like this technique where you just tell it, hey, I've got this function, and it's going to return you a set of parameters or a set of values, and the first one's going to be a Boolean, the second one's going to be a float, and you can keep adding them. Because the tuple class is flexible, you can tell it, you can keep adding parameters, and some of these parameters can be arrays, they can be objects, whatever you want to put in here, but you're going to get back an object of type tuple, and then you just interrogate, item 1 and item 2 is how you get the values out of it. So that's pretty clean, and it's strongly typed. You're saying, compiler, only let me do this if I'm calling something that's going to return a Boolean and a float. So it's a little bit more predictable and self-documenting to do it that way. Okay. So lots of different ways to return multiple values. Returning nothing is easy, returning one thing is easy, and then when you get to returning multiple things, you got all kinds of places you can go from there. Any questions? Okay, go back to the list. Returning a reference from a method. Yeah, that's what we're talking about there. We're returning references to things. Something else I wanted to ask is, like, if I'm in these functions down here and I'm returning a new of something, I'm creating an object. So you remember, hopefully from the first class, the difference between the stack and the heap? Did you go over that? Okay, so when you compile a program for the Windows execution model, your program by Windows is given some stack space and then access to functions that it can call in the operating system to get memory back that it needs to use. Okay, when you compile the program though, it's got a parameter in there that says, hey Windows, my stack is going to require this many bytes of stack space. So when it loads that program from disk, it's going to go out and grab a blob of memory, and it's going to say, okay, here's your stack. Use it how you will. Have anybody ever heard of a Stack Overflow? Okay, not the website, not stackoverflow.com. They're using that name to be clever, but okay. So if you have a recursive function, a function that calls itself, and it gets out of control, every time that function gets called, it passes the parameters in the stack. It says, okay, I'm going to use the next 16 bytes of the stack, and I'm going to copy my parameters up there. So then I call this function, and the function says, okay, where's my parameters? It looks in those spots on the stack. So it's this protocol between the calling function and the called function as to, here's your parameter copies by value. Okay, got them. And then when the function returns, it just moves the stack pointer back to where it was before the called function, and now that's free to be used again by the next call. So where that stack pointer is and how much stack is currently being used varies while the program executes. It's constantly growing and shrinking as function call depth gets longer and shorter. Okay, well, if you're calling a recursive function, it's an undetermined number of depths that's going to get called, and if it goes too far, it can run out of stack space that was allocated it when this program was started, at which time Windows says, no, I'm not going to let you continue writing past what I gave you, so boom, I'm going to kill that program and say this program failed with a Stack Overflow error. So, so that's the stack. And then if your program is sitting there saying, I really need to allocate a bunch of memory to manage this table of values that I just read from the database, then you can say, hey, Windows, could you give me 20,000 bytes of memory someplace that I can use to write stuff? And it says, yeah, sure, here you go, as long as it's got it. And it's up to you to manage that however you want to. And when you're done with it, tell Windows, hey, you can have this back now. From time immemorial, the problem with that model is, and C and C++ programmers had a devil of a time with this, is they would allocate memory, then their program would crash, and the memory would still be allocated. Windows says, well, this program over here allocated it, and it didn't tell me it was finished with it. And so it keeps doing that, and eventually it runs out of memory, and Windows says, okay, we're done. I can't continue. I can't even pop up the dialog box that says an error happened, I'm out of memory. And then you get a blue screen. Okay. I'm getting off on tangents here, but it's kind of interesting to me anyway. Back in the early days of the interwebs, when we had Internet Explorer 1.0 and Internet Explorer 2.0, back in the late 90s, we were trying to build a website called Expedia. And so they wouldn't let us put our code into production until we had shown that it could run under certain kinds of stress tests for 72 hours. And if it did, then you got the green light, and it's like, okay, this is stable. You can take it and you can put it out on the servers for everybody to use. Well, it was really hard to do that when Internet Explorer itself had memory leaks out the wazoo, and just running Internet Explorer to hit the web server over a 72-hour period, you couldn't keep the test machine running. It wasn't our problem. We didn't have the memory leaks. Internet Explorer kept crashing the machine. And it took several versions. By 3.0 and 4.0, that was pretty stable, and we didn't have that problem anymore. But it was a little challenging there. So we had to write scripts that would run Internet Explorer, hit our web page, get the result, close Internet Explorer, make it go away, then run Internet Explorer again. You couldn't go to a second website. You had to run a new instance of it to keep doing that so that Internet Explorer wouldn't run Windows out of memory. So that's the heap. It's managed differently than the stack. The program manages it, but then the program is the one responsible for making sure you don't run out, or that you're responsible and give it back when you're done with it. It's like your neighbor using your shovel and never returning it, right? It's just bad form. Okay. So, all that to say this. When I have parameters, traditional normal parameters, that is being managed on the stack. The compiler writes all of the logic for handling the copying of whatever's in these variables at the time to the stack, branching to the function, and the function looks in the expected place to get those values, processes, returns, and then the compiler makes sure that the code correctly puts the stack pointer back where it was supposed to be. We don't have to manage that. The compiler creates the code when we compile our program to do all that correctly. However, when we say create a new object of type whatever, the code that gets generated goes to the heap and says, can you please allocate me memory big enough to hold a Boolean and a float? And, okay, great. What is that? 12 bytes or something like that? Whatever it is, it'll add up how big that object needs to be, and it'll return you 12 bytes from the heap, and that's yours to play with. So the question is, like in C++, we spent all kinds of brain cycles figuring out, okay, who allocated it and who is responsible for giving it back when we're done with it. But we're not doing any of that here. So how does that get managed in C#? We created a new object, we allocated memory on the heap, we returned it to this function up here, we assigned it to this variable, okay, we handed the baton. Now the main function has responsibility for this memory that got allocated. Okay, we come down here and we hit the close curly brace. Okay, excellent. We'll deallocate it then. But, you know, remember this very first function up here where we called, we fired and forget, and we didn't care whether it worked or not. Maybe that's what I want to do here. So if I just call the function, well, the function is going to create a new object. It's going to return it, but I didn't accept the baton. What happened to the object? You know, I don't have a reference to that variable anymore. So who's deallocating that memory? Okay, well, I say all that to just point out that C#, they have spent a lot of time and energy to create this language to be what we call in a class of languages that we would call garbage collected languages. And I'm not sure you could say that they came up with the idea. I think they were mimicking features that were becoming popular in Java at the time. Java is also one of these languages that you don't have to worry about that so much. The runtime environment, it's actually called the Java runtime environment, the JRE, handles keeping a list of all of the little 12 bytes and 16 bytes and 47 bytes that get allocated while your code is running. And then it checks that list every now and then. It has a separate thread in the background that runs periodically, and it goes through that list and says, hey, I got an object here, I got a tuple on the list that nobody's referencing. Go ahead and delete it, it's gone. So it doesn't happen necessarily instantly, but eventually it will get cleaned up. And you know, they probably got all kinds of policies built into that code where the tighter we're getting on memory, the more often the garbage collector runs, and the slower your program runs. So if you've noticed things like your phone, which a lot of those apps are built in Java, or your Xbox or your PlayStation or your computer, they start to get slow and they degrade before they go poof. That's probably what's going on. It's getting more aggressive about trying to reclaim things as the space gets tight. So I just want to point out that when we're talking about returning references from methods, you got to worry about the garbage collection stuff that's going on there. And like, we wouldn't want to design an algorithm that calls a function that allocates a bunch of objects that we don't care about, because all of that creating objects and then abandoning them, there is a price to be paid for that. Your memory footprint, and I don't know if you guys have seen this, but let's see if I can debug this. I think it's probably just gonna, I probably need to set a breakpoint there. Hello world, oops, check your input, yeah. So I want to stop down here. Where do I click? Put my breakpoint. Oh, there it is, okay. Debug, start debugging. Here we go. So if you look over here on the right, I can't zoom this in because it's one of the fixed windows in Visual Studio. But notice it says process memory and CPU percentage. It will tell you, like let's say we were running this inside a loop and objects were getting created and deleted and created and deleted. Then it would show you as this thing was running how many bytes we were allocating and how many bytes we were responsible for So lots of cool features in here. But anyway, if you wanted to monitor and see how your program is doing, then keep an eye on this little diagnostic tools box while you're debugging your program. That was all I wanted to point out. Okay? And none of this is obviously in the chapter. I'm just trying to throw it out there to add value, to tell you why we're talking about these things. Okay. What next? Returning reference, overloading methods. I have an example on overloading 2. Let me see if I can open that one in Visual Studio. Open project. I thought that there was an open from source control thing. Yeah, I want to open from, oh, maybe it's Git. Git, clone repository. There we go. All right, so the scenario that I've created here is, let's say I want to print a name. The simple naive approach is you just create a function that you pass it a string and it has a console write line and it just prints the name, right? No big deal. Then I want another variation of it. Let's say sometimes I have logic in my code where I have a last name and a first name. So the people using my program, maybe sometimes they want to pass both parameters separately. And the scenario here would be, let's say you're getting this name value from user input. You say, please enter your name, and they type Mark Snyder and hit enter. And so you've got one string that contains the whole name. Okay, well then I want a print name function that just, you pass it one string and it prints it. But this next scenario, maybe I'm reading this one from a database and there's 2 different fields. And so I create a print name function that takes the first name and the last name, and I format it the way I need to format it based on my requirements and output it that way. So essentially these 2 functions do the same thing, but they are taking different sets of parameters, and that's what we call overloading. We're overloading the name of the function with multiple parameter types, with the assumption being that you're probably doing this because they're doing the same job with different sets of input. You know, you could create every function in your program, like, you know, whatever assignment I give you, you could use the same, you know, Mark's function name for all of your functions and just use different parameter sets depending on what you needed that function to do. But like I said, the implication here is you're doing this overloading technique because they're related in some way that makes sense to you. And like you see here, it's because they're all going to be printing the name. Okay, the next example is, you know, anybody know somebody from Spain? You know, in Spain, when you ask them what their name is, they pull names from like their father's surname, their mother's surname, and, you know, they have a whole list of names. So let's say we're reading from an international database, and, you know, the person comes back here and says, oh, my name is, you know, Mark Edward Aurelius Chrysanthemum Snyder, and I have to format that. Well, how do I do that when I don't know how many parameters it's going to be. I don't know how many names are going to pass me. So that's where we get this cool feature. Like I said, well, I think we talked about this last time, but it is pretty nifty. You can define a parameter list, and it's simply an array of parameters. I made a string here, but there's no reason why you can't make it a string of object or an array of objects if you need to make it other stuff, or an array of int parameters. But the key is you have to put the keyword params in front of it so the compiler knows, oh, this is one or zero to many other names are going to be in this array. So it's always got to have at least two, and then it may have a third or more. Make sense? So notice I only have first name, last name, and other names, but this function call has 5 parameters that it's passing. So when it calls it, the first name parameter is going to get assigned Snyder. The last name is going to get, well, and I've got it screwed up already, but, well, okay. Let me fix that, because that just looks weird. It's going to hurt my brain to leave it that way. Okay. Now it makes better sense. So I passed, in the second example there, I pass the first name and the last name, but I print last name, comma, first name. Got it. In this example, Mark gets assigned to first name, Edward gets assigned to last name, still a little bit of a misnomer, and then these 3 remaining parameters get assigned to this array of strings called other names. And so pretty simple to process. Last name is last name, first name is first name, and then I have a for loop to process all of the strings in other names and print comma space and the value for that name. But I guess, okay, so that is the topic of overloading methods, okay, and parameter lists. But now the last thing I wanted to talk about was ambiguous situations. So my question is, this one's fine. I only have one function that takes a single string, and that's this one. So the compiler obviously is going to take this call that is past one string, and it's going to say, yeah, this is the only one that makes sense. Of all of the print name functions, the functions named print name that I can find in this compiled program, this is the only one that makes sense to call with this single string. But what happens with these other 2? Because, so when I call with 2 strings, I got 2 print name functions that are a possibility here. I mean, this one with the params, it would handle this just fine. So you might say, okay, well, fine, just comment this one out or delete this one. We don't need it. This one, generic one, will handle both of those. But it still leaves the question, how does a compiler know which one it's supposed to call? Does everybody see that dilemma? I have a function call that takes 2 strings. This function definition takes 2 strings, but this one also takes 2 strings and then optionally more strings. So which one? So we've got a situation of ambiguity here. And the compiler doesn't like those things. People that write the compiler don't like those situations. They like everything to be deterministic. The same thing's going to happen every single time. Yeah,
What would happen if it were to compile?
let's see. Works just fine.
Is it doing both?
You think it's calling one and then the other?
Yeah.
Maybe.
Or you think it says, well, on this one I picked this
Yeah,
function,
that's what I was thinking.
so for fairness sake, I'll send this one to the other one. No?
Yeah.
And it doesn't flip a coin, you know. Let's, I'm gonna comment out that, I'm gonna comment out that. Oh, looky there. So this one, it grayed out and it left this one. So I would say that at least Visual Studio thinks that the compiler is gonna pick this one.
Yeah.
But what I was gonna do is I was gonna set a breakpoint here and a breakpoint here and just see which one it calls when I run it. Debug, start debugging. And sure enough, Visual Studio was right. It called the one with 2 parameters and not this one. Okay? So, the lesson to get out of this is situations of ambiguity can occur in C# in your coding, in your programs. It can be ambiguous as to which one might be called. The way C# resolves this is they have disambiguation rules. It says, and in general, the intuition is the more specific, the higher priority. Okay? So it says this only has 2 parameters. And so even though I have 2 functions that I could call, this one only accepts 2 parameters, so it's higher in the disambiguation rules list. It's an exact match. I'm going to call it over the other one. So they just write that into the language rules. In the case of ambiguity between which function to call, if you got an exact match, that's the one you're going to pick first. If you don't have an exact match, if you have 2 different ones that you could call, no, that's interesting. So what if we had it'll equals double quote. Now it's not an exact match for either one of them, right? Still compiles. Do I still have my, no, I deleted my breakpoints. So it still calls that one. So again, we had a question, is it going to give us a compiler error, or are the disambiguation rules going to take the closest match if there's not an exact match? It looks to me like it picked the closest match.
I was gonna say, why would it pick that one when the middle one, is that one the closest match to what the parameters were? Because it would be the same thing, because the other one has parameters, the parameter string for the other names, and the other one doesn't have a middle name. Okay.
Yes. Yeah, so again, we're learning. It prefers default parameters over parameter arrays, parameter lists. So the people that wrote the compiler thought about this and they said, no, I think it makes more sense to pick the one that is not an exact match but only has default values as opposed to the one that's not an exact match and accepts parameter lists. Complicated, huh? Fun stuff.
I got a question.
Yeah.
If you took it even farther and then you did like string first name, string last name, string middle, and then you had another one that said first name, second last name, would it maybe just go alphabetical order?
I don't know. Nope. It apparently likes default values more than it likes parameter lists. Now the question is, what about this one? Because I think now we created a situation where this one is not even going to call this print name, the one with the parameter list. I think this one is going to call this one with the default values too. So yeah, interesting stuff. I like that I got you guys thinking of permutations. When in doubt, write a quick console application and test it. Yeah, and that was all the topics for this chapter. So I think I will probably just cut it off there. Any last questions before we stop?